everybody. Welcome to Old News, the museum's monthly webcast, bringing you news from the paleontology world. So my name is Laura Beth, and I'll be your host. So I'm going to keep an eye on this chat room. I've got the computer here so that those of you watching live can ask questions, and the museum's research curator of paleontology can answer those questions because very smart and expert about dinosaurs and all things prehistoric. Dr. Christian Kammerer.
Thank you.
So, Christian, what is new? Because we've got this ichthyosaur fossil, and I feel like we already saw that in episode 1. So are we talking about ichthyosaurs again?
Sure thing. So we do have this specimen here, which we've been showing off, which we first pointed to in episode 1 of Old News. We are going to be talking about some other marine reptiles today. So actually something that's very closely related to ichthyosaurs. So marine reptiles were incredibly abundant and diverse during the time of dinosaurs. So dinosaurs themselves did not live in the ocean, but you had a lot of these different marine groups. And that's especially true in the Triassic period. So that is the beginning of the age of dinosaurs, the first period of the Mesozoic era.
So that's before the T-Rex?
Yes, long before T-Rex. This is, some of it is actually before any dinosaurs. But Triassic is between 250 and 200 million years ago. And so in addition to having the fish lizards, the ichthyosaurs, and then these long-necked marine animals, the plesiosaurs, there was also a wide array of marine reptiles that died out and weren't around later in the Mesozoic. So if we look at the slide actually that we have here, we can show off some of the diversity of those. So you have these animals called placodonts, which are like false turtles. They are similar to turtles but not related, and they have crushing teeth for eating shells. You have things like Tanystropheus, which had a neck as long as the rest of its body. These really weird things like Van Clevia.
It's like a tadpole.
Yeah, or almost sort of even like a dragon, where its tail fin was actually made up of bony plates rather than sort of soft tissue. So there's a lot of different sort of strange Triassic-only marine animals. And more ones are being discovered all the time, especially in these very rich Triassic beds in China. In fact, since we are at Old News dedicated to bringing you up-to-the-minute paleo coverage, this is one that was named just this morning.
This morning?
This morning, yeah. This was published. This is an animal called Panzhousaurus, which is from the Middle Triassic of China. It's a relative of sort of the long-necked plesiosaurs and their relatives. But we're not talking about that one today. That is just the latest thing. So we're going to be talking about a group called Hupehsuchians.
I like the way that sounds. Hupehsuchian.
Yeah, Hupehsuchians. So it means crocodiles from Hubei province in China. They're not actually crocodiles, though. So you can see in the art here, it has this long, pointy snout, and they are early relatives of the ichthyosaurs.
Yeah, they look very similar.
Similar skulls there. So the first Hupehsuchians were described in 1959, but it's not until like the last 10 years that we've really found enough fossils to start to say what they looked like. And here are some of these recently discovered skeletons of them. These are ones that were published back in 2014. And so you can see they have that ichthyosaur-like pointy skull, but then they have a more crocodile-like body with a long tail without a dorsal fin like ichthyosaurs have. And they also have this very strange rib morphology. So if you look closer at the ribs of these things, it forms sort of a bony tube or a carapace. So the drawing to the right there, you can see the vertebrae, the backbone, that is in brown. The ribs are in blue. And then there are these orange things, which are the belly ribs. So belly ribs we don't have them in mammals.
Are they actually ribs?
They're not true ribs, but they are support structures for the internal organs.
Okay.
But in these Hupehsuchians, they form sort of this lattice work or this network across the body to make it really into a bony tube, presumably for protection of these animals. So it's very, very strange. The animal that I am going to be talking about today is is a creature called Eretmorhipis, which was first described a few years ago based on these headless specimens. So partial skeletons, not with all of the elements, and missing the skulls. So this was already known to be, recognized as a new species and recognized to be somewhat unusual compared to the other Hupehsuchians. So for example, if you look at its hand, it has this odd morphology where it has 5 fingers, like we do, like most land vertebrates have, but it also has this little bone marked E on the drawing, which is an extra wrist bone that is making the hand wider and generally more sort of like paddle-like, more flipper-like.
So it can like swim,
for
push
it to
water away.
swim through.
Easily.
And there's a lot of variation in this in Hupehsuchians. Some have only the 5 fingers, some have fingers and extra carpals, which are the wrist bones, like Eretmorhipis. Some have as many as 7 fingers. And that's actually similar to something that we see in ichthyosaurs and other marine reptiles. So if we can go to the specimen here. Yeah. So this is the flipper of the ichthyosaur, and it has 2 features which you sometimes see in marine reptiles, which are polydactyly and hyperphalangy.
Okay.
So polydactyly means many fingers, poly many, dactyl finger, and you can see in the ichthyosaur it has 1, 2, 3, 4, 5, 6 fingers instead of 5 like we have.
Okay, so like this is a finger,
Yeah,
right?
that's a finger there.
It looks very different from our finger.
Yeah, they're very specialized. And then it also has hyperphalangy. So in our fingers, we have 1, 2, 3 joints in them. Each of those is a bone called a phalanx. And if you look at the ichthyosaur, instead of just having 3, it has upwards of 15. Each of these little discs is a finger bone, is a phalanx.
So that means they could have, our hands are not very flexible. They could have bent their hands, or their fingers even more.
Well, so actually our hands are more flexible than theirs would have been.
Oh, okay, right.
So because they have all of those little bones here, it forms sort of a uniform flat fin. So they could not bend. They could not bend each of these independently. It just would have stayed rigid and propelled them through the water. So this is a very specialized morphology in ichthyosaurs, but you see versions of that in other marine reptiles, like in these Hupehsuchians. So Eretmorhipis, it is already just a little weird, even
just by looking at the hands.
Just looking at the hands. Yeah. But just recently, last month in fact, new skeletons of Eretmorhipis were discovered.
They found the head.
And they found the whole thing. They found that the head attached to it, and the head is very, very weird. You can see how tiny the head is compared to the rest of the body. It doesn't look like the other Hupehsuchians. It doesn't look like the ichthyosaurs that have this very long, pointy snout for catching fish. They have giant limbs compared to the head. They have these weird triangular bony plates on the back, presumably some kind of armor. And the unusual appearance of this has led it to be called sort of like the platypus reptile. So like when you think of, like a platypus, they are... they look kind of like a hodgepodge of other animals. It has a beak like a duck. It has a tail like a beaver. It has a body more like an otter. Indeed, when the first platypuses were sent to England during the British colonial days, they were thought to be a hoax put together.
Oh, really? Like they thought they were...
They thought they chopped up other animals and made a fake, which they did at the time. They made, mermaids and dragons through taxidermy.
Yeah.
So maybe not unreasonable, but platypods definitely are real. So is this animal Eretmorhipis. And if you look at the skull, though, there are even more platypus-like features to it. So you have the skull, in this picture you have the skull at the top and then the lower jaw at the bottom here. And something you'll notice about the skull is that the tip of the snout diverges. Look at the green lines here.
So it's in 2 pieces.
Yeah, it's more like a fork or, sort of like forceps. And that morphology is only known in one other animal, and that is the platypus. So if you look at a platypus skull, it doesn't have just a flat bony beak like a duck does.
Mm-hmm.
It has these two prongs to the snout. You can see the lines diverging there to make this sort of fork-like shape.
Mm-hmm.
And you see it in platypus, and you see it in Eretmorhipis, and that's basically the only animals that we know of that have it. This is side-by-side illustration in the original paper.
So the blue part on the platypus, that's where the actual beak would have been, right?
Yeah. So that is...
Or do they call it a beak in a platypus?
They generally call it the bill.
The bill, right?
Yeah.
Yeah, that makes sense.
But they do... So if we can look at that picture again, you also see there's a little bone in the center there that's labeled OP. That is the os paradoxum, or the paradox bone, which is of unknown purpose in the platypus even today. And very weirdly, Eretmorhipis has the same thing. So this is just a remarkable amount of convergence between two very, animals that are very distantly separated in time.
So these are the only two animals that we know of that have existed ever in the world.
Yep, of millions and millions of species. Yeah.
So these are the only two animals that have the paradox bone.
Yep.
So what do you think it's for?
So because the skulls are so similar, convergence generally occurs when two different groups of animals are doing the same thing ecologically. So if they are eating the same kind of food or living in the same kind of habitat, they will start to look similar. And sometimes it's pretty rough, like the ichthyosaur, as we've seen before, looks kind of like a dolphin or kind of looks like a shark.
Right, yeah.
But it is, because it's so specific between Eretmorhipis and the platypus, they must have been doing the same thing with this skull. And we think that was probably how they were feeding. So with the platypus, if you look here, platypus swims through the water and goes through the mud with its bill. Its bill is very sensitive, and it can sense electricity as well, so it just sort of plows its way through the muck, trying to find little things to eat, little worms.
So it's eating
or shrimps
right now, or it's foraging, like to try to find food?
Yep, exactly.
And so, are those its eyes?
So those were actually little bits of fur around the eyes. So it closes its eyes when it's in the water and it's feeding, and it's just sensing through the bill. And we think actually, so Eretmorhipis must have been doing the same thing. It must have been using that very specialized snout to go through sediment, in its case in the ocean rather than in rivers like the platypus does, but in order to filter out little food to eat. And that also keeps with its skull being so much smaller than that of other Hupehsuchians, which were probably eating bigger sort of fish and prey like that.
Wow. That's so cool.
Yeah, it's a weird critter, but it really shows how very strong selection towards certain body types.
Because they're not related at all, right? Like the
Eretmorhipis.
Eretmorhipis.
Yep.
I'm gonna get that right. The Eretmorhipis
It means fan oar because of that hand. Also, is like an oar of a ship.
Okay, right.
Yep.
So that is a marine reptile, right? And the platypus is a mammal. So they're completely different.
Yep.
There's no lineage. Okay.
And also very separated in time. So this creature lived, 240 or so million years ago, and platypus is still alive today. Although they do have a fossil record going back, 70 million years or so.
Oh, really?
But still pretty separate in time.
Yeah.
No platypus existed when Eretmorhipis was alive.
Right. Yeah. All right. Well, if you guys have any questions, let us know. I like the model that we have today.
Talk about this one?
Yeah.
Yeah, highly
He
accurate.
actually told me to bring in a platypus, and I was like, I'm gonna bring my Beanie Baby. Going with our theme of childhood toys, Patty the platypus.
It unfortunately seems to have had some traumatic event in its life where it's lost the tail.
Oh yeah. Well, they weren't really purple either, so I guess we can't, trust the Beanie Babies to always be accurate, scientifically accurate. All right. Well, if you ever have any questions about the platypus or any other prehistoric creatures, you can always email us at outreach@naturalsciences.org. And we will see you next month for old news. We are going to be connecting on the last Tuesday in April. So,
all right. Thanks, Laura.
Thanks, everyone.
Bye.
Thanks, Christian. And thanks for watching. Bye. I want to like show the platypus as it runs through the muck.
Like that?
Yeah.